this formula here for you. Find the length of this guy, parabola y squared equals to x from 0, 0, 0, 0 to 1 and 1. So you have initial point, then you have your terminal point, and question says, okay, find the arc length. There you go. So if you want to apply the formula here, it says you have your function y equals to f of x, right? Y equals to f of x. So it means that they have to take the square root of both hand sides and then start taking the derivative. There you go. Okay. Arc length 0, 0 to 1 and 1. Y equals to f of x. So it means that our y is equal to, let's take a look at this. First of all, what's the graph like? How do we graph this guy? From 0, 0 to 1 and 1. This is our graph. 0, 0 to 1 and 1. You want to know what is this length here? So y is equal to plus minus square root of x, and y prime is equal to plus minus a half x to negative a half. Then very well, our L is equal to integral 0 to 1 square root of 1 plus minus a half x to negative a half raised to second, or just 1 over square root of x. Okay. So here L is equal to the integral 0 to 1 square root of 1 plus 1 over 4x dx, or L is equal to the integral 0 to 1 square root of 4x plus 1 divided by 4x dx. So recall that if y is equal to f of x, we use L equals to the definite integral a to b square root of 1 plus y prime raised to the second power dx. What if I want to use the arc length with respect to variable y? Why not? Here you get square root of 1 plus x squared to the second power dy, and x is a function of y. Let's try this guy. Maybe it helps us to calculate this integral in an easier way. So x is equal to y squared, x prime is 2y, okay. Then L is equal to my y starts from 0, goes to 1. So this is my C, this is my D. Zero to 1, square root of 1 plus 4y squared dy, which is the integral 0 to 1 square root of 1 plus 4y squared, or squared, which is, here you don't have to do that, 4y squared dy. So remember the type when we have square root of a squared plus x squared, we use trig sum. Using trig sum, you can calculate this integral. So in this case, you can say that, well, here, if I just take a look at this, it's 2y squared. So if I take my y to be a half tangent theta, then you can take the derivative with respect to y. So remember that tangent is sine over cosine. Then on the numerator, you get 1. On the denominator, you get cosine squared. So you get secant squared theta d theta. Then you can substitute all of these here. Your L is equal to the integral. So here you have square root of 1 plus, you have 4, and then here you have y squared. So you can cancel out these two, 1 plus tangent squared theta, a half secant squared theta d theta. This gives you can bring a half in front of integral, you get secant theta times secant squared theta d theta, which gives you a half integral secant to the third theta d theta, which is equal to a fourth secant theta, or if we use boundaries. So if you plug in 0, if y is equal to 0, then your a half tangent theta is 0, tangent theta is 0, or theta is 0. If y is equal to 1, here you get 1 equals to a half tangent theta, or tangent theta is 2, or theta is inverse tangent of 2. And this is your upper bound. So here we get 0. Let us call it alpha, or just write it as inverse tangent of 2. So here you have a half secant alpha, tangent alpha, with a little bit more space. We need another a half, right? Yes. So we get another a half because we have outside. Not this one. Here a half. And then here we have ln of, so positive, I'm not sure, secant theta plus tangent theta. Then we're going to plug in 0 to inverse tangent of 2. Then you can calculate this number, plug that in, and eventually you can use your calculator to calculate this length. Calculator to calculate the rest, and substitute this theta. We don't need alpha. Calculate the length for you.